Now, as the name suggests, breadth first search. What happens in breadth first search is it goes, explores all its children, then proceed to the next vertex or next node. Now, the vertices in breadth first search are divided into levels, just like a tree. And we start with the vertex at level 0. That means some vertex we have to pick up that will be at level 0. We consider that to be at level 0. Then we have to identify all the vertices that are reachable. That is what is breadth first. So all its children, or all the nodes or all the vertices which has the edges, we have to find those. Uh, we will- we have to visit those. Then once we visit in the next round, again we have to find a new vertex or identify a vertex which is now at level 1, second level. We are coming to the second level, and that vertex which is not visited, we have to visit that vertex. And this process will continue until no new vertices are found. So breadth first search works level by level. Now let us take an example. This is the graph what we have for breadth first search with 8 nodes. I mean, this is the graph we have. For this graph, we have to compute the breadth first search, and this graph has 8 vertices. Now what we do is we start with vertex 1. You can start with any vertex, it doesn't matter. But usually what happens is we pick vertex 1 as the start vertex. We start with vertex 1. Then, since we are performing level by level, we are considering level by level to visit nodes or to know that nodes are reachable or not. So we will take help of a queue. And then we will also have an array with the number of nodes. And this array is known as array, which shows us whether the vertices are visited or not, whether they are marked as visited or not. So what we do is we start with vertex 1. So when vertex 1 is selected in the breadth first search, we output the vertex 1 and then mark the vertex 1 as visited. Here tick mark, you can see I'm marking it as visited. Then what are the edges of vertex 1? There are 2 edges, vertex 2 and vertex 3. But how do we know we have to find the the edges of vertex 1? That is at level 0. So what we do is, as we mark this vertex, we put that vertex in the queue. So vertex is, the breadth first search result is printed, the vertex is marked as visited, and that vertex is put in the queue. Then we pop, this is not a stack. We remove the element from the queue, that is vertex 1. Whatever element has been removed from the queue, from that element, or that whatever vertex is removed from the queue, from that vertex, we try to find what all vertices are reachable. Now in this case, vertex 2 is reachable. So we put vertex 2 in the output vertex 2, mark vertex 2 as visited in the visited array, and then we enqueue, that is insert into the queue, vertex 2. Then the next reachable vertex from vertex 1 is 3. Remember, it's vertex 1 we are saying because that is the vertex we have removed from the queue. So 3. So 3 gets the printed as the result. Then we mark 3 as vertex 3 as visited and insert in the queue. Obviously, when we insert it was inserted after vertex 2 at the end, from the end. Then all the vertices which are reachable, vertex 1 is over. In the next case, we remove the element from the queue. Now it will be vertex 2. vertex 2, from vertex 2, note vertex 4 is reachable. So we output 4 and we mark 4 as visited, place 4 in the queue. Then another vertex 5 is reachable from vertex 2. So we mark vertex, we output vertex 5 as the result of the breadth first search and mark vertex 5 as visited and put it in the queue. Then all vertices which are reachable we have already explored. So we again pop out the element. Now it is vertex 3. We again remove the element from the queue. It is vertex 3. From vertex 3, we can reach vertex 6. So we display vertex 6 the output, mark vertex 6 as visited, and put vertex 6 in the queue. Then vertex 7 is also reachable from vertex 3. So we output vertex 7 and we mark vertex 7 as visited and insert vertex 7 in the queue. All vertices are explored which are reachable from vertex 3. So we again perform remove operation on the queue. Now the removed element is vertex 4. The vertex which is visible, reachable from vertex 4 is vertex 8. So we display vertex 8 and then we mark vertex 8 as visited. Now obviously after marking vertex as visited, we insert into the queue. Now all the edges are explored from vertex 4. Then next element is then again remove operations performed. Vertex 5 is removed. Vertex 5 is already visited, so there is no need to visit vertex 5 again. Then again remove operations performed. Vertex 6 is removed from the queue. Vertex 6 is also visited, so there is no there is no need to visit vertex 6 again. In the same way, vertex 7 is removed from the queue. It is already visited, so there is no need to visit vertex 7 again. And finally, we have vertex 8, which is removed from the queue. Vertex 8 is already visited, so there is no need to visit vertex 8. Now, there are no more elements in the queue. So when there are no more elements in the queue, that means we have completed breadth first search. So initially, the first element which we are trying to start exploration of the breadth first search, we select that element, we mark it as visited and put in the queue. And then subsequently all the reachable vertices are selected, put in the queue. We remove from queue and then try to find its reachable vertices, and this process goes on until and unless the queue is empty. So this is how breadth first search works, and you can find that we have a breadth first search output displayed. Now let us look at the algorithm for breadth first search. Now this algorithm breadth first search, the very first thing is we mark this the vertex 1 as visited. That is what we start. I told you we start with. We repeat, then we repeat until the queue is empty actually. So we will have that statement within the algorithm. Now for all vertices W adjacent to V, that means we are exploring vertex U from U, we are exploring vertex U. So when we explore vertex U, all the vertices which are adjacent to vertex V, if the vertex is not visited, then we add that to the queue, insert it to the queue and mark it as visited. Now this process goes on, all vertices. If they are not 0, we add it to queue and mark it as visited. Otherwise, we don't put in the queue, we just, the for loop ends. Then if queue is empty, we return. Otherwise, we delete U from queue. That is, we remove that vertex. Then again, repeat happen because we are deleting a vertex U. Then again, we are in the repeat loop. We find all the vertices W which are adjacent to U, perform the same steps. If queue is empty, we return. That's a very simple algorithm for breadth first search.